Welcome to day 7. Day 7 is going to be FCP and this little N with that exclamation point. I'll explain what that N with that exclamation point means. But FCP stands for the Fundamental Counting Principle of Multiplication. It's based on what must you select and how many options you have for every selection that you must do. So for student council, we have to elect a president and a vice president, and our options are, I'm just going to make up names, Mary and John and Bridget, Tim and Lori. So what are the possible outcomes of this election? Well, we have to select a president and a vice president. So just using the first letters, I could have Mary and Bridget, Mary and Tim, or Mary and Lori, or we could have John and Bridget, John and Tim, and John and Lori. So counting our ways, we have 6 possible outcomes. But was there another way I could figure out the number of outcomes? Well, let's talk about what we must do. We must elect a president and a vice president. So I'm going to put little blanks here. And it's all based on multiplication. I must select these 2 roles that are going on here. My options, so my number of options for president is 2, Mary and John, and my options for vice president is 3, Bridget, Tim, or Lori, and I multiply that together, and again I get 6 outcomes. So this is really based on what must I select, how many options do I have for each selection, and I multiply them together. Okay, Bob's Restaurant offers a diners a choice from each of the following for some special. Entrees there are 2, potatoes there are 3, vegetables there's only 2 options. Green is not a single vegetable. Dessert there's only 2. Ice is not a dessert. And beverage I see 4. So how many different specials are there? Well, again, it's based on what must I select. 1, 2, 3, 4, 5. Multiplication between them. I must do an entree, a potato, a vegetable, a dessert, and a beverage. And what are my options? 2 times 3 times 2 times 2 times 4. I have 96 different dinner specials that I could order at this restaurant. Seems like I could go there for about 3 months and not order the same thing. So some license plates, like the state of Ohio, are 3 letters followed by 4 numbers, such as A, B, C, 1, 2, 3, 4. And I have to use 26 letters in the alphabet for the letters and 10 digits. 0 through 9 are, which is 10 digits. Don't forget the 0. What happens if I'm allowed to repeat things, such as getting AAA 1111? So again, I have to have 1, 2, 3, 4, 5, 6, 7, letter, 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 digit, 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 multiplication between each process, and my options are 26 here, 26 here, 26 here, 10, 10, 10, 10, and as a big number, 175,760,000 different ways I could make license plates this way, like the state of Ohio. What happens if I'm not allowed, if I cannot repeat? It's a big stipulation. So I still have 1, 2, 3, 4, 5, 6, 7, letter, 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 digit, 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 1, 2, and dots in between because I'm multiplying. But now I cannot have the same thing. So my first letter I have 26 options, but my second letter now I only have 25 because I can't use that first letter. My third letter I only have 24 because I can't use either of the first 2. My first digit I have 10, including 0. And then I only have 9, 8, 7 options. And now all of a sudden I only have 78,624,000 ways I can do this. I got rid of many options based on not repeating. Get rid of, let me erase that a little bit. I got rid of more than half of what I can do. Almost lost 100 million ways. Using 4 digits, using the numbers 1 through 8, I am allowed to repeat. So 1, 2, 3, 4, and all multiplication. 1 through 8 is 8, 8, 8, 8. 4,096 ways I can do this. Now, I cannot repeat, but I still have 1, 2, 3, 4. 8, I can't use this one. 7, can't use this one. 6, can't use that one. 5, and now I only have 1,680 ways. I lost a lot of ways. I lost a lot of numbers I can do. A basketball team. The starting lineup of a 5-member basketball team, well, I have 1, 2, 3, 4, 5 guys on the team. I do the first starter. There's only 4 guys left. There's only 3, 2, 1. I have 120 ways that I can announce the 5 members of the starting basketball team. How many ways can I rearrange the letters, 3 letters F, C, and N? FCN, FNC, CNF, CFN, NCF, NFC, and I see 6 ways possible. Okay, or 3 letters, 1, 2, 3 letters, 3 choices, only 2 left, only 1 left. Again, gives me 6 as my result. But let's look what we've done in these last 2 problems. These last 2 problems I did 5 times 4 times 3 times 2 times 1, or 3 times 2 times 1. And these examples are the very special key I was talking about earlier. It is called factorial. That is the end with the exclamation point. It is a special key on the calculator. And I'll show you where that key is at. As you see, you must type the number in before. You want to do things, and it's not too hard, but n factorial means something special. So the 2 examples that we did was 5 factorial and 3 factorial. Well, if I want to do 5 factorial, I have to hit the number first, 5, hit the math key on the far left, move it over to the probability menu right over here, move it up to right to the probability menu, and number 4 is at a little exclamation point. And that says 5 factorial. I hit enter, I get 120 because 5 factorial means 5 times 4 times 3 times 2 times 1. 3 factorial, oops, 3 factorial, we saw was equal to 6. So this factorial key means something special. So n factorial means n times n minus 1 times n minus 2 are, you basically, n factorial means you start at the number n and multiply down until you get to the number 1. Or even better yet, n factorial, let me get red, n factorial is just n times n minus 1 factorial, all the previous terms. So like 1 factorial is 1, 2 factorial is 1 times 2, which is 2, 3 factorial is 1 times 2 times 3, which is 6, and so on and so forth. So we're going to use our calculator to do all this stuff. Using our key, now technically 8 factorial would just be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is a lot to put in your calculator, so an easier way, just type it in at 8 factorial, you get 40,320. 10 factorial, again you just type in your calculator, 3,628,800. 20 factorial, as you can see, these are getting big. Your calculator says 2.433 times 10 to the 18th. So When we talked about exponential functions were really the strongest of all the functions, we just found a stronger function. 10 factorial is a very big number, a lot bigger than 2 to the 10th or 3 to the 10th or 4 to the 10th. Okay, so factorials are actually the fastest growing functions. It's just that they're not really continuous functions. You can't do 7.5 factorial like you could do 2.5 raised to the x. But they grow very, very quickly. Now the next example, I could type this into the calculator. And when I type this into the calculator, let me get rid of that, I get 90. And that's very easy to type in the calculator. But another way to think about this is that 10 factorial is 10 times 9 times 8 times 7 times ... And 8 factorial is 8 times 7 times ... So I do notice that, wow, all these 8s and 7s and downs are canceling out. The only thing left over is 10 times 9, which is 90. Maybe that's a better way. Why do I say that? Because for this next problem, if I put this in the calculator, it is too big. And it gives me the error message of overflow. So when I do that in the calculator, I said, well, if I can't do it in the calculator, I better rewrite it as 100 times 99 times 98 times 97 times boom, 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 boom. And 98 factorial is 98 times 97 times all the way down. And when I do all that, 98s and 97s and all that cancel out. The only thing I left over is 100 times 99, or I get 9900. And this last one, I just put into the calculator as is. And 5 times 6 times 7 is only 210. It's not a big number, but 5 factorial times 6 factorial times 7 factorial, it is 435,456,000, which is quite the big number. So I told you, factorials grow quite quickly. So how many ways can I rearrange the letters Y-O-U, Y-O-U, Y-U-O, O-U-Y, O-Y-U, U-Y-O, U-O-Y, 6 ways. Of course, I would have been better just to do this, 3 times 2 times 1, or 3 factorial, and I would have got my 6 ways. That would have been easier. So let's look at the word wow. Got a little bit of problem here with the word wow. I have a repeat of the letter W, so there's only W-O-W, W-W-O, and O-W-W, and that's really about it. After that, they're all going to be the same 3 ways. So there was only 3 ways. So my question is, why? So if I want to rearrange the letters in Y-O-U, it was 3 letters, 3 factorial. If I want to do the letters in WOW, it's going to be the number of letters factorial divided by the number of letters that are repeated factorial. So for my example, it would have been 3 letters in WOW, 3 factorial, over the repeats, 2 W's, 2 factorial. 3 factorial is 3 times 2 times 1, which is 6. And where's my eraser? 2 factorial is 2 times 1, which is 2. And you see I get only 3 ways. So let's apply that to a big word like bookkeeper. Well, bookkeeper has 10 letters, so it's going to be 10 factorial. But I do see 2 O's, 2 K's, and 3 E's. So it's going to be 2 factorial, 2 factorial, 3 factorial for all the repeats. Now you have a choice. You either have to put this in your calculator and make sure you put parentheses around the whole denominator. So I need to use parentheses. Or or use that fraction bar key that we've used already throughout this unit. Either one will work. Make sure you group them. You plug this in the calculator and you get 151,200 ways that you could rearrange your letters in Bookkeeper. So let's do our names. If I do my name, which I go by Ray, I'm going to get 3 factorial, which is 6 ways I could do it. If I use Raymond, which I don't really use, I have 7 factorials, no repeats, 5,040 ways I can do it. If I do Scrunchy, my last name, I have 7 factorial, but I have 2 n's in Scrunchy, divided by 2 factorial, which is 5,040. 2 factorial is 2. I have 20 ways in which I can do that. So, FCP, Fundamental Accounting Principle of Multiplication, based on multiplication, and n factorial or factorial. And again, that's really just a fancy way of writing a special way of multiplication.